this talk. Today, we are going to talk about web attacks. But first, few important things. First of all, I would like to start this class by congratulating to Martin, who won the best teaching assistant ever in CTU. So a big applause for him, because this is super awesome. Yay! Best teacher ever here. And few other things that we have. Last class was okay. The pace was just right. So I hope that it's going to remain like it. First of all, can you see the text? Is it too small, too big? All good? A little bit bigger? Okay. Another test, can you see this? Or bigger? Yeah, we will make it bigger probably. Okay, this is probably too big, but okay. All right. So, Pioneer prizes for the last assignment. On the third place, winning this awesome keyboard thingy, Octopus AD keypad, is Sereda1. Do we have Sereda1? No? No, we don't. Okay, then we will probably keep the prize if they don't show up in 1 hour or so, because this is a very cool thing. All right. Next one, second place, winning this multifunctional LED clock. Awesome thingy if you like to play with electronics. Luca Sedan. Yay! We have our winner here. So congratulations. Awesome. And on the first place, winning this. Okay, no, this is not the one. This is the one. This is a cool thing because it's in the box. Way better. First place is Max. Hey, congratulations, Max. Here's your prize. Great. So before we go into web attacks, few things to say. We got the dates of final exams. Please note them down. As we said last time, please do not leave it for the last date. The exam is not super easy, and we won't be adding more dates. So please come as soon as you can. Have fun on our exams. You can take as many of them as you want, and they are going to be really hard, I would say. And don't forget, please, to register in COS. It should be, as far as I know, the dates should be already available in COS for you to register. And as for bonus assignment, the one that when you finish it, it allows you to skip the whole problem with the exams. So it will open on December 19th at 21 p.m. And the deadline to finish all assignments in the bonus assignment, or all, like problems, or solve all problems in the bonus assignment, and to publish the report, it's by the January 7th, okay? And by the way, today is the deadline. Is it correct, Martin? To submit the unlock reports, exactly. So please, if you are interested in doing the bonus assignment, you have to submit now. Okay? That's it. Any questions for the exams or for the bonus that allows you to skip the exam?
And also, a lot of you already submitted the unlock reports, and you should already have some feedback if it was approved or we want you to modify something. But if you submitted not yesterday and you still don't have any feedback from us, so please get in touch so we can see if we made some mistake in gathering all the submissions.
Any questions? Bonus, exams, anything? No? Okay, cool. Sorry? I think we don't have one, do we? No, we don't. But we have challenges in Strato Cyber Lab, And we have 2 interesting applications for you to hack that are not an assignment, but you can try to play with them. So let's wait until we get there. Okay. One few things that I forgot to say: bonus report submissions are final and cannot be edited. Okay. We can ask you some questions to clarify, but reports cannot be edited. So when you submit it, it's final. That's it for you. Okay? You can submit it before deadline, it's completely fine. But the submission is final, no edits after that. We can ask for clarification or for something like that, but you cannot edit the document. And final details, rules and everything, we will talk about it in the next class next week. Next week is going to be about advanced web attacks, and it's going to be Sebastian who is teaching it, and me. And please, those of you that are using Stratos Cyber Lab, please start your class 12 now, because there are a lot of services there. It's going to take some time for it to start, okay? Internet, any questions? I guess no, because we didn't talk about it. So first of all, today we will talk about web. What is web? You know, what are the rules on the web? Like, what does the web consist of? Then we will talk mostly about Reconnaissance, and then we'll deep dive into some vulnerabilities that are very, very common on the web. So my question for you is, what is web? Sebastian 3 years ago said that it's where the stuff is. I think it's pretty much like self-explanatory, but so what do you think is the web? Any ideas? First of all, it's not just like, I mean, when you go to like google.com, it's not just the page that you see, right? Because there are so many different technologies behind like this simple web page. There are so many services, reverse proxies, databases, like tons of them. So it's like a convoluted set of different and connected technologies all together that are like doing, yeah, the stuff, and that shows you what's there. So what actually happens when you run curl google.com is that you will probably end up at CDN, and like it's actually HTML, right? But there are so many different technologies that talk to each other, so it's very, 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 very convoluted. It's a huge distributed system that starts with your end device, like on the client side, desktops, mobiles, some bots, stuff like that. Then there are some middle boxes that are, you know, routing stuff there or adding some more information for other parts of the infrastructure that is running on the server side. On the servers, we have databases, we have application servers, we have so many of other things that are doing a lot of compute. And all of that is like very much connected, and it's very complex. Okay, so first rule of web is that like assume that everything is more complex than you think it actually is, which also leaves a huge like attack surface for you as hackers, as penetration testers to exploit, because all of these boxes behind each other probably have a hole in them that you can use and try to get inside. And the more boxes there are, the more holes there are, okay? So, for you, way easier. First of all, today we will be using something that's called OWASP Juice Shop. OWASP Juice Shop is intentionally vulnerable application for training, for you to try different types of attacks on the same application. Okay, so OWASP, by the way, OWASP is an organization that is monitoring the web. It's gathering vulnerabilities. They are publishing a lot of tooling. They are making conferences. It's very interesting point. It's very interesting resource for you to read about and to train with when you are trying to break into cybersecurity world. Okay, so. There is one version that is live, OWASP Juice Shop Heroku app. We will not be using that one. We have our own instances, okay? So for those of you who are sitting here, please, we will do something that's called port forwarding. Who does not know what is port forwarding? Okay, let me rephrase. Who knows what is port forwarding? Raise your hands. Okay, this is good, this is good. What we are doing is that we are basically doing a tunnel from your computer inside our network that we are running. Okay, our juice shop is running safely on our infrastructure, and now what you will do is to create a tunnel to access this juice shop instance. All right, so we have 3 instances. We will do very simple load balancing. Please pick one of them. It doesn't really matter. I would say you guys pick juice shop 1, you guys put juice shop 2, and you guys please take juice shop 3. You do the port forwarding like this. So there is so what you are saying is like, okay, port forward port 3000 on my local machine to juice shop running somewhere in the network. And then you are also port forwarding port 8888 on your local machine to Juicy Engines, where you are requesting port 80. And this is the command that you are using when you're accessing your container. Okay, so this is the port of your container in our Docker lab. Okay, so what I do is that I copy this command. I have a one port 9106, which gives me access to my container. Okay, and on localhost, I should be able to access my OWASP juice shop. Okay, are you able to do that? Can you see this? Yes. Yes, in your own computer, exactly. Not in the Docker, inside your computer, the same way as you are accessing, for example, the container that you are using for the rest parts of the class. You run this SSH port forwarding, and you should be able to access it from your local computer, okay, inside your browser. Anybody has a problem? No? All good? Everybody can see Juice Shop on their local machine? All right. For the internet, it's basically the same, but you don't have to choose the instance, of course, but from your SQL Hacker Lab. So let me just start the Hacker Lab so everybody knows. This part is only for the internet, okay? This one is not for you if you are using our class. So I run my Stratos CyberLab. It's here. I go to web class 12. I start it. There are instructions for you, okay? So first one, connect to the class lab with command this one, and admin for password. This one you have to run from here, okay? Like this. Oh, password, yay, I'm in. And this one, the second one with the port forwarding, is the one that you run from your local machine, okay? From your terminal, like this. Okay, so you open terminal, you do it like this. It's asking me for the password. Password is bytedem 123. Yay, I'm here. Now you should be able to access your OWASP Juice Shop as well. All right? Internet, if you have any questions, we have Murray, we have Martin who are here and can help you with anything. All right? Please make sure that you can access the OWASP Juice Shop on your local host, because otherwise it's going to be very hard to follow the rest of the class. All right? If you have any questions, please ask. And this is the same for you people here. If you have any questions, please ask. Interrupt me and just say that there's some problem, okay? Great. So let me just stop this. Good. Now, the result should be that all of you are able to access Juice Shop. As I said, we are past that, we are good, and we are good to go to the rest. So, before you are able to pen test something, you have to find it. It's hard to try to break something if you don't know where it is, right? This first part is called Reconnaissance, or information gathering and reconnaissance. So it's a process of obtaining information about the target's infrastructure. Like, because before we can actually attack something, we have to know what to attack. This process of reconnaissance is different for each infrastructure, is different for, even you can do reconnaissance on a single application. So we are trying to discover infrastructure, software, processes, sometimes even people, because when you want to, or when you are asked to physically attack a company, we are also very much interested in people. Or when you are testing, for example, phishing defenses, then we are also interested in people, because the more you know about people and the company, then it's easier to attack them. Still reconnaissance, right? So the goal is to gather as much information as possible. So if you know what to attack, then you can start attacking. Now, easiest way how to actually find some cool things about a company is actually just to Google, right? I mean, Google is like the greatest database ever built. I mean, they know everything about us. They know where we go. They know what we do, and a lot of the information you can actually just Google for, okay? So, and for that, it's super awesome. They have this Google Advanced Search, where you can specify like conditions on what you are looking for, right? So this is not. I mean, probably when you are using Google, you just put, okay, closest restaurant to me or something like that, or how to fix this error, right? Or how to fix this exception and whatever. And probably LLMs are better in that. But did you ever try just to Google for like a stack trace and discover a running application with this stack trace? Because it turns out it's very common, and you can actually just Google for vulnerable things. So for example, you can find open directories. You can find, oh wow, okay, I can find, but my Google is probably refusing to find, not sure why. But with this one, what you are doing is that you are saying, Google, hey, in titles, like in title of the page, we are looking for index of. If something is open, so for example, think about it this way, if you are exposing a directory that's just for internal use, listing, like the listing one, this should be in the title. Not sure why my... Does it work, by the way, for any of you? When I was testing it today, it worked quite well. Not sure why it's showing some weird things. Yes, this is the one I was talking about. Okay, so when you are searching for, in title, you are actually searching for this one, for index of. Like this, you can find like so many open directories on the web. I mean, when you're looking through the whole web, it's not that like useful, because when you are pen testing someone, you probably have a scope. But you can also like scope all of these searches by using site. All right? So when you are doing, I don't know, site reconwave.com, okay, I'm not a bot, thank you. It gives you like only the domains reconwave.com. So if you are searching for a vulnerability in a company, you can use simply site and your Google Dorking query that you decided to use. All right, there are other interesting ones. So for example, known directories for WordPress. Yes, Univerzita Palackého v Olomouci, not great. So you can find like so many open directories, sometimes configuration and other things like this. Super easy, by the way, everything is public. It probably should not be. So again, if you are running pen test for a company, use the site, okay? Because that one like does your scope. There are other things, etc. Why is etc important? etc is important. It has configuration of your file system, and even some logs. You know, like this one gives you logs. Hopefully, I know why it's not working. Like this. Hey, we have error log. Okay, this one is empty, so not that interesting. Maybe this one is more interesting. Yeah, there are some config files and whatnot. There are so many of them, so many resources talk about Google Dorkin. I totally recommend it for you to check it out because it's just interesting what you can just Google for and how many credentials can you find and things like that. With Martin, by the way, this is not theoretical thing. With Martin, we reported more than 20 exposed database connection strings and configuration secrets and API keys and all of that was just there lying in the Google data. Question, how can you defend or how can you protect your site against this? Apart from, of course, not making mistakes and exposing everything. Any ideas? I have cool things here. Okay, I have chocolate for you. Sorry? Yes, I do. Okay, this is certainly something. I think that would work. That will work. But the thing is that your content will be there for some time. So you would have to know that your stuff was indexed and it's there, right? But it's good. Like I will try. I'm sorry, I'll probably fail, but yay! Okay, this was cool. Okay, I like it. Any ideas? Apart from DMCA takedowns, they are good. How can you prevent that? Like even from going into Google's database? Sorry, no? Okay. We have robots.txt. It's a very simple way. So what you do is that, let me just fix this for you. Robots.txt notifies like search engines if they should index your website, right? So what you can do is that you allow index on the important parts, on the public parts, and then you basically disable everything else. So even if you leak something, the search engines should not like put it into their database. By the way, this is optional. They don't really have to follow these rules, so it's basically up to them. But important thing I would like you to know is that Google is like very powerful. They have a lot of very interesting data from the security perspective. Any questions to this? No? All right, so moving on for something more interesting. Application discovery. So in the previous section, we like just Googled 4 things. This is not very systematic, let's say, and not very optimal. But we can also like target on search. So for example, there are typically like 2 different ways how a company or anyone basically can host their applications. Okay? Now we are talking about infrastructure. All right, so we are in a process of trying to find all about the company in terms of what infrastructure are they running, what applications are they running, and where are they running it. Okay, so typically there are 2 ways how to host application. Let's say we are trying to host GitLab. Okay, we can use a separate domain or subdomain for our main domain, or we can host it in the path, all right? So we have, I don't know, mycompany.com/GitLab, and I'm hosting my GitLab there. I can also host it on a subdomain. It's also very good. So how do we find subdomains? Well, let's start with the domain, okay? A domain is a human-readable identifier with some hierarchical namespace. So we have dots in there that are separating parts of the domain. And human readable is important because nobody here, well, not most of us, can remember, IP addresses. So I'm not sure about you, but I don't even know IP addresses of our own company. So, so we have reconnaissance.com that I can remember, and I know where it is. I don't have to remember the IP address, right? So subdomain of a domain is a prefixed Domain separated by dot. So this is a subdomain. Okay, we are all clear here. From now on, it gets a bit more complicated. Who knows what DNS is? Everybody, I guess. Correct? Who does not know what the DNS is? Okay, great. So basically, it's a system, translates domains to IP addresses. Also, DNS can store so many interesting data in TXT records. By the way, we have a very nice link on a talk that we give with Martin on the B-sides about DNS and TXT data. And because all of you know what the DNS is, can you tell me how many types of DNS records there are? And by the types, I mean, okay, there are A's that translate IPv4, there are 4A's that are IPv6, there are CNAMEs, of course, TXT records. Anybody has a guess how many of them there are? Like this. It's a useless technical trivia, but I love it. No? Okay, so there are more than 80 of them. I don't know why, but there are 80 of them. Interesting fact. So, the thing how DNS works is that there is no query. Like, give me all subdomains, give me all DNS data, give me all domains that you know. The query is always, okay, give me an IP address for this domain. All right? So it's like a one-way mapping. But, so just using DNS, you are unable to find all the subdomains. Okay? So you are unable to find like all, I don't know, GitLab instances, all the instances of different applications that people are running. All right? So, but there are other options how to find subdomains. Do you have some thought how to find it? Any ideas? Like, okay, if I give you a task, hey, please, can you list all the subdomains for I don't know, reconwave.com? How would you approach it? Any ideas? Yeah. Yes, this is good. This is good. Actually, this is yeah. We just Google for it. It's awesome. I do it all the time. It actually works. So, good idea. Another actually yes. Let's try it again. Nice. Okay. Okay. So basically brute forcing, correct? We have like a huge dictionary of domains, and we can just try to resolve them. If it resolves, yeah, there might be something around. Yes, this is another one. This is the brute force. There are many different lists that we can use. So basically, there are people that are scraping the internet and building all these lists from most common subdomains. We can also use LLMs to create this list, because if there is just one list that's like a similar for everyone, we can have like a way more contextual information about the company, and we can put it to LLM and tell it, hey, please generate possible subdomains for this domain, because they are in a cybersecurity, they have this amount of developers, they are probably using these systems and like that. So yes, brute forcing. This is very good. There is one exception. So these are called wildcard zones. What it means is that basically when you put anything in front of the domain, like anything as a subdomain, it can resolve. It will always resolve, because the domain is using so-called wildcard DNS record. So it basically says, hey, if user tries to resolve anything, just give it some data. It does not necessarily mean that there are some applications running. So for example, if you try to resolve like this DNS record, it will give you IP address, but there's nothing running. It's just like empty response. Okay, so if you are using brute forcing, you should be smart about it. All right, because otherwise you will end up with thousands records that are not saying anything, and there are no applications running behind them. All right, and this whole brute forcing works only because people really tend to like short and self-explanatory domains. So when you are deploying GitLab I don't know how many of you are working in companies that are using GitLab, but I bet you that your GitLab is running under gitlab.our domain, right? So by the way, how many GitLab instances are there on the world? Do you have a guess? Another guessing? No? Okay, is it 10,000s? Is it hundreds? Is it 100,000s? Is it millions? Any guesses? Do we have internet guesses? Can you check if anybody is guessing on the internet, because I reveal it. So as a part of my job, with Martin, we have a company, we are scraping the internet, so we know all the domains, okay? And there are 1,839,000 domains that are GitLab dot some domain. So GitLab is a fairly popular system. And the last very obvious way how to find subdomain is Certificate Transparency Project. Not sure if you heard about that one, but very basically it's a database of all HTTPS, and not only HTTPS, but all certificates ever created, okay? So when you are deploying your application, for example, with Let's Encrypt, because everybody is using HTTPS nowadays, every single time when you create a certificate, it will end up in this Certificate Transparency Project, okay? So then you can very basically just use it to search for existing subdomains that have the certificate issued, which are like almost all of them, okay? So this is very good choice. You can also find, it's not just for HTTPS, because you can find people there. It's awesome. When you try to search, for example, so there's this site, cert.sh, that is basically logging it. You can find so many interesting emails there. Do you know why? Why are there personal emails of people in the Certificate Transparency Project? Okay, not just, okay, let's try Proton Mail. Any ideas? Again, I can try, okay, I mean, Christmas are coming, so here, I have a very nice, almost Christmassy tree. This query, yes, this query works. So, any guesses? Yes, Max? Is this related to the OWASP backup, because there's so many emails? This is good, yeah, I mean, it's not directly to Datova Skranka, but the principle is basically similar. The point is, when you want to... It's for, yes, actually a bit differently, because this, why this happens is when you request a digital certificate for you to sign emails. All right, because some organizations and some people want to be able to sign their emails, like literally with a certificate claiming, yes, I did write it. Okay, so these are coming from the personal certificates that you can get here in Czechia. I'm not sure if in the world is the same. I would guess yes, but yeah, I would say as well, but with the proto mails, there are just few of them. But for example, with the Centrum or Seznam emails, there are like so many of them. So I would guess this might be very specific to Czech Republic, where people were, getting their digital signatures for emails, and all of that was leaked. Well, not leaked, it's by design. So it was there. Yeah, so many other projects are scraping this Certificate Transparency Project. There are many applications that you can use to discover it. So you can just browse it, and it's very good source for defining scope or for when you are doing reconnaissance on a company. We also have a very simple website, so if you want to, feel free to use it. If you write me that you heard about it today, then I will give you a premium account for free. And you can see all the subdomains of domains or anything that you basically need. But like doing this manually is very hard. Nobody does that anymore manually, so we can use tooling to discover all subdomains. For that, I have an example with Asset Finder. Asset Finder is one of them. There are, as I said, like a lot of toolings. So in your containers and yes.
We have a question for a little bit earlier.
Yes.
Couldn't you use dig or NSLOOKUP to dump the list of A records, which would show the subdomains?
So this is a special case. In short, no. But there are thing called zone transfer. Zone transfer is a very specific way how to actually request all DNS data from some name server or from some DNS server. And if this zone transfer is enabled, the DNS server will return all the data it knows. Nowadays, it's considered misconfiguration, so please, if you are operating some DNS servers or name servers, do not enable it. It's not a good idea. Yet, from our research, it shows that around 8%, Martin, is it 8%? 8% of all name servers have their zone transfer enabled, even though it's considered a misconfiguration. There's a blog post on our site about this, so feel free to read more. But yes, in some cases it is possible just to request all data from DNS server, but it's misconfiguration, so it's probably not going to work for your specific case. All right. So let's try with the Asset Finder. With this one, we try to find all domains that are somewhat related to felg.cvut.cz. So let's try in our containers. Oh, I did it wrong. Yeah, so many of them. And sometimes it's not even felg.cvut.cz, because it's also able to find some domains that are probably in the HTML data of sites it visited, or they were somehow related. It does not mean that these are operated by CVUT, by the way. So whenever you are using this tooling, please check that whatever it returned, it actually makes sense. Okay? All right, so this was subdomains. Now, to the apex domain, so to the root domain, so to mycompany.com. How can you find other apex domains that your company owns? Any ideas? So we know how to find subdomains, that's good. But I'm not sure for which company you are working for, but I would bet you that the company is using more than one domain. It's not just mycompany.com, but it's probably mycompany.cz, maybe mycompany.de. Any guesses? How can you find like more Apex domains? No? So this is actually very, very hard. There is no silver bullet for it. We have whois, but it's not great. So ideally, we would use whois. Whois is a service that is operated by ICANN that is actually issuing those domains. In the whois database, you can just try whois, I don't know, sesnam.cz. It's all of this, a lot of data. Sometimes it tells you who owns it, sometimes it does not. So yeah, you can't really know who owns reconwave.com. Other than that, it's probably in Prague. But yeah, thanks to that, you can't really tell how many domains you own. But there's a really nice trick for the bigger companies. If they are operating their own name server, you can just check who is using that name server. So, and then you can just correlate them by the name server. So when I was talking about Sesnam, we can see that Sesnam has these AMS name servers. So of course, novinky.cz, they have the same name server. So if you know all the name servers, then you can try to find all the domains that are being used. This works only for bigger companies because the smaller ones are usually not using their own dedicated name servers. All right, so this is just a small trick how to do it. Any questions for subdomains domains part of Reconnaissance? No? All right. So let's go to paths. As I said at the beginning, you can host application in the subdomain. We covered that. We are able to find it now. Or you can host it behind a path in URL. Sadly, there's nothing like path transparency project, so you can't really, just go to some database and list all the paths this company is using. You can still Google for them. Yeah, that's definitely possible because, as I said, in Google there's so much interesting stuff for you to find. So the only thing that you can actually do is to brute force it. Again, there are many different word lists. You can find them here, and there are many different tools. For example, today we will use GoBuster. I really like GoBuster. It's very cool. It can do a lot of stuff, and you can find a lot of stuff. And again, as I said, with the subdomains, if you know the context of the company, their jobs, what they are doing, what is their aim, what they are hosting, and stuff like that, you can again just ask LLM to generate some paths for you to help you with the brute force. So if you know this is a medical company, they might be running, I don't know, some medical systems. I don't know anything about medical. But for example, if you know they are developers, they will probably have some, I don't know, Git, some Grafana or something like that. So it might help you to generate like existing paths. There's this really nice prompt if you want to play. But let's try to brute force something. Now, this is my favorite part. First of all, we will be using this awesome domain. I don't think it actually exists because I don't think there's a tld.bsi, but we redirected your traffic inside your containers to our instances. But please check if this actually returns private address, which it does for me. This way you are not brute forcing internet, okay? So every time when you are testing something, please make sure that you are doing what you think you are doing, okay? We had some typos. We got some reports from testnet that we are attacking the whole internet. It's not great. Yeah, so let's try to brute force something. So what we are gonna do is that we are going to use GoBuster. We will tell it, okay, we are trying to use directory brute forcing. We will use the domain class12.bsi, and we will use this awesome word list we prepared here. So let's try it. Yay! So we found something. Did your command work as expected? Did you find something? So here you can see, I mean, I can probably keep it running if we don't shut down our own server. But very basically what we found are some URLs that are /redirect, /next, that are redirecting to some other domain, okay, example.com, not super interesting. But there are these two applications that we found. Yay, awesome. This is good. And we have also YouTube link. Can you guess what this YouTube link is? Yeah, Max knows. Cool. We have also one more application, and there are some hidden treasures. So let's try because this is interesting. So we can do it like this. What's here? Okay, definitely not here. So as you can see, we found some existing directories. As you can see in here. All right. So we found paths, we found some redirects, and we found 3 applications. All right. This one, app.class12.bsi. This is the, sorry?
A little bigger.
A little bigger? Okay. I'm not sure if I can make it bigger. App.class12.bsi. This is the one that we will be using. This is actually our juice shop. So that's good. There's pub.class12.bsi. We won't be using this one, but it's an application where it was used by thousands of people. Martin found XSS there, so if you can replicate what Martin did, it was actually very, very, very cool. And the developer fixed it after Martin's report. And the last one is the one I was talking about. This one is for you to try to hack. It's an application that's running now on your 000 like this. If you did the port forwarding, it's an application that's based on Next.js and it's based on React. All of them have totally default settings. So if you have a free time, either during break or after the class, and you want to try to hack something that broke the world a week ago, like I totally recommend doing this one because it's awesome. All right, and this one, the pub is running here. Again, feel free to play. By the way, I can see people suggesting these ones. If you go to this URL, it's not gonna work for you in your browser because it's redirected only in the terminal. So in here, yeah, it's gonna work, but it's not so great because sometimes for hacking you need a browser. So these two are accessible on our localhost like this. So if you go on HTTP localhost 88888, you will get the pub one, and if you go to 000, you will get the next one. All right? If you are interested in trying to break them, please do. Please beat something out of them. I'm really interested if you are able to hack it. But for today, for this class, we will be talking about the juice shop that's in here. I mean, you can't really tell from all this HTML that it sent, but it doesn't really matter because it's running on our localhost. All right. So we found the running OWASP juice shop. All right. This is the application we were looking for. It's awesome. It's great. So we can go further and start analyzing the application. Any questions to infrastructure reconnaissance, how to find as most as you can about some company when you are doing penetration testing? Any questions? No? If not, okay. Very important part, by the way, okay? Infrastructure reconnaissance, very, very, very important. Now we move to application reconnaissance. So we want to discover as much as we can about the web application. All right, so about the application that we will be now targeting with our penetration test. Great. So what we want to find? We want to find basically everything that we can. We want to find, okay, where are all the entry points? Where are all the inputs? Where these inputs are turned into outputs? How user-generated content is treated if they are, I don't know, checking what we are putting into the application. We want to discover everything about their API. What API are they using? What technologies are they using? What is powering their web server? Where is the web server running? How is the web server running? We want to find out about what cookies are they using? How are they using the cookies? How they process parameters, and basically anything that we can about the application. Because again, if you don't know what you are testing, you won't be able to break it. Well, if the application is stupidly easy, then probably yes. But the more you know, there's higher success of you breaking it. All right? So, there are a lot of different tooling that helps you with application analysis. For today, I want to be, as much bare bone as possible for you to learn. But in the advanced class next week, we will use some way more fancy tooling. So today we will use Google Chrome, actually, your browser. I'm not sure what browsers are using. Firefox has a similar feature, but it's super great because in Chrome Net Export, there's a feature that allows you to record all the interactions your browser did with a website. Okay, so very basically, this is just a fancy logging solution for your browser. So we can simply start recording all our interaction that we had. So let me just close the tabs that I don't need. I will start logging. So now my browser is saving network events, so whatever browser did with network. And now we can go and start just exploring what we are doing in the application. I also recommend like turning on the developer tools, so you can see what endpoints and how they were called from the application. Okay. So, what do we do with this application? I can see search bar. All right. So, hello world. All right. So what it did is that it used an endpoint. Yeah, I can see. I'm not sure if you can see it. I'm not sure if I can make it larger, but it tried to call localhost REST products search with the query endpoint. If I try something different, it's again trying to search something. All right, so that's the search. We have some reviews. Okay, cool. Can I vote on reviews? No. But again, I can see that there is some endpoint reviews, and there's a. I can't enlarge it. This is not great. Sorry for that. But there's an endpoint. Endpoint. What else? Okay, we have customer feedback. Oh, I can send customer feedback. Hello. To what is this? It's two. Okay. Yay. Okay, we did send. Okay, so there's some CAPTCHA endpoint and who am I endpoint, continue code endpoint, things like that. What is here next? About. Okay, so some reviews. Again, it's asking for some data. This is good. What else? Photo wall. All right, it's loading something, but there's no way for me to interact with it. This is good. And then I saw login. Okay, login is good. Hello. Can I log in? No, invalid email. What did it do? It did login. Okay, it did login, so there's login endpoint and things like that. All right. So in the first phase, what you are trying to do is to learn as much about the application as possible. So we now found multiple endpoints that we can use. Oh, there's, by the way, a registration. Okay, this is good. This is good. So there are many different things that you can discover just by looking. Okay. So whenever you are doing this, you are trying to find all input fields that you can, endpoints, authentication mechanisms, and other things that help you to learn more about the web page that you are running. Now, because we recorded all the interactions, we can stop it. We don't need it anymore. Now, two things: either you can use the export that I created for you, and it's already in your containers. You use it like this, or if you want to see what you just did, then this command is for you. Okay, so this one is for you to explore. I didn't want to put it here directly because everybody has a very different data, because everybody clicked on the different things. But if you want to, feel free to play it with this JQ. JQ, do you know JQ? By the way, does anybody here not know JQ? Okay, JQ is a tooling for you to discover, to be able to visualize JSON files. Okay, and it allows you to filter for them. So it's a CLI tool that plays very nicely with JSON formatted data, because you can filter. Yeah, you can filter where you are basically saying, okay, give me all events, but select only type 2 and select only the ones that have URL and stuff like that. So it helps you to discover JSON data. So now I will use the one that we created for you before, and with this JQ query that basically says, okay, give me all params.url, aka give me your URLs that you called. I can also see all the APIs, all the REST endpoints, and everything that I interacted with. All right? So this way we used network logging in Chrome to help us to find all the different endpoints that application has. All right? The juice shop. There's also another way how to do it than playing with JQ and figuring out all the parameters and all the things that you can use, because you can also use BSI clipping or basically any LLM where you can tell it, okay, here's some data, you know, like the export log. This is a Chrome net export, find all endpoints that were used, what was the payload and their URL. All right, so it's thinking when I try to pass it here. Yeah, it works pretty nicely. LLMs can help you a lot when you are doing pen testing, okay? Oh, we broke it. It's cool. Look at this. It broke. Nice. We broke an LLM. It's in the infinite loop. Okay, this is cool. I was not expecting this. Let me try again, by the way. So whenever you are using all this data, LLMs can help you a lot with the analysis to help you to figure it out what data there are or what you actually did. But I can also, so this is this case, okay? We passed some network log, we didn't know anything about it, we passed it to LLM, it told us, hey, there are these endpoints, all right? There are these endpoints. Sometimes it can even tell you, okay, here's some query string that you can use for some reason. Okay, APIs, application configuration, so many of these things. So LLMs can help you a lot with pen testing. Okay, they can help you to analyze data, and later I will show you how LLM can even craft data to hack the application. So this was useful. Yeah, here's also an example. I'm not sure which model are you using because a lot of models perform differently on this example. I used model GPT OSS, that's quite big. Not sure if you can run it on your computer. If so, I envy you a bit. But smaller models are usually a bit worse. Also, you can't really pass the whole net export because when I tried it, I really quickly ran out of context. So you have to process the data before you actually pass it to LLM to reduce the context or to reduce the size of the file that you are passing it. By the way, don't forget to disable network logging, okay? Because it's generating a lot of data. Because your browser is doing so many different network connections all the time, it's crazy. So please don't forget to disable the logging. All right? So, any questions for this part, for Reconnaissance? All right. So, what we did is that we were looking for an application. We were looking for things that we want to break. We found it. Then we mapped the application. We discovered what the application is doing. And now, after the break, we will talk about how to break it and how to get in. All right? But first, we will have to go through all the most common misconfigurations and problems. All right? So let's have a break for 10 minutes, and let's see in 15:42. All right? Great. Thanks. very important for us. Not using from. Because from cannot do this. You see, you're switching between two. Yeah, but the one that are even past this is either. No, you cannot configure it in Chrome. You can configure it separate. Yeah, this can do it for break and virus and I don't like bread, so it's the only word we have. You also have the problem with break is that you have to disable the system. Otherwise, it's unusable. But with Forst, you are able to disable everything. So very hard work.
Ale nechtějí to být na A druhá věc, než to kopírovat, tak dej tam Martin vždycky tak nějak jako systém
What? It's oh shit. Maybe because people run the brute forcing and it's doing some logging. The application, I would say that Juice Shop is logging something. Maybe because everybody here ran the brute forcing, it's creating a lot of logs. I mean, I can try to, you know what? Try to maybe restart all the computers. Well, not the Juice Shops. All three. Sorry? Yeah, I heard. Yeah, okay, so if you are running out of space, I would suggest maybe restarting the juice shops. Not everything, just the juice shops. Okay, I would... Now we will talk about OWASP top 10, so it might be okay, but I don't know. I will ask Martin. Martin? Yes, but also Makalo just ran out of 2 terabytes of space, so we might. I think that we just yeah. Can you talk to Marie about it? I would say that it's because of the brute forcing that it generated like so many logs. Because if everybody did brute forcing, it might have. It's in the Docker Compose in class 12. So maybe we should just, you know. It's class 12. I don't know if it's Nginx or if it's Juice Shop or something. Anyway, I'm starting. Yay! Okay. Are we here? Yes. So just a quick note. We are brute forcing, and we probably brute forced a lot. So our server is experiencing difficulties. We run out of 2 terabytes of data. Good job. So if you are running the brute forcing, can you please, you know, Command C or just like stop it? It would be good. Meanwhile, our awesome people here, Mari and Martin, will try to solve it. But let's talk about top 10 most common vulnerabilities on web. I already mentioned OWASP. So the OWASP Foundation is tracking reported vulnerabilities and maintains a list of top 10 most common web vulnerabilities. So we will go through the concepts. Okay, what are the most common ones? The latest list that is currently valid is from 2021, but they are working on an updated version starting this year, 2025. So I will go through that one later. So without looking, what is the biggest problem that most of the web applications have? Any guesses? Like, have you ever, I don't know, like think about, okay, what is probably the most commonly broken thing in the web app? Any thoughts about this? Okay, never mind. So it's a broken access control. What does it mean? It means that somebody who is not supposed to is able to access things in the web app, right? Do you remember from the very beginning of the class when we just Googled for some logs? Yeah, this is broken access control. Like, nobody should be able to access your logs. Nobody should be able to access your data, of course, without authorization, okay? If you have authorization, you should be able to do whatever the authorization allows you to do. However, the most common vulnerability or problem with the web applications is broken access control. So please, when you are building your applications, always check if the user that is accessing this type of data is authorized to do so. One of my favorite problems, there are in a web are so-called IDORs, indirect object references. So for example, how does it work? Like, this is great vulnerability. We will talk more about it in the advanced class, but very basically, a lot of applications have a problem where they check if user can access the application, but they don't check if user is able to access this particular data in the application. So think about it this way. If your user is able to access, for example, a data of organization 1 with ID 1, he should not be probably able to access data of organization 2, right? If he can, it's IDOR. It's a problem. It's a broken access control. By the way, that's one of the reasons why you should probably use UIDs instead of integers. Because if I am using your application and I know that my organization is ID 1112, I am definitely going to try to access data on 1113 because I can just add 1 or, you know, like add 2, add 3, and I can enumerate all your organizations that you have. With UIDs, you really can't. I mean, I can keep guessing, but at that point, I would rather guess private keys to Bitcoin wallets than your UIDs in your application. Okay, so broken access control, super important. Any questions for broken access control? No? All good. All right. Second one, cryptographic failures. Also, very important one. Rule number 1 of cryptography, never ever roll out your own cryptography, okay? Always use existing libraries, ideally with the safe configuration that is always described in the manual. All right, very important. I know that we as software engineers think we can do everything, but like this is exactly the part where you should leave it to people whose job it is to write these libraries. Super important. And as you see, it's number 2 of the most common issues with the web. So it's usually a failure to properly set or define or enforce all encryption, hashing, privacy settings, also certificates. Legal things also fall into this part. So GDPR, if you are operating on the global scale, very important things. Okay, data of your customers from Europe should not end up in US. Otherwise, your legal department is going to be very angry with you, and it's not great. Yes. Oh, sorry, Martin, Mike.
Thanks. So I'll ask the obvious question: why can't you do this yourself?
Sorry.
Why can't you do your own cryptographic solution?
Yeah, okay, because cryptography is extremely sensitive to all sorts of attacks, and everybody will try to attack your own cryptography. So cryptography, like all the cryptography that we have right now, very much relies only on the knowledge of the private key, or of the key. It's called Kirchhoff principle, I think. So think about it this way. The only thing that your security should be based on is the knowledge of something secret only you know. So if attacker knows everything else about your system, has access to all the code and all the configurations and everything but the private key, they should not be able to get inside your system or inside your, I don't know, encryption or signatures and stuff like that. And to ensure this, so to write a library that is as good as what I just said, it's extremely hard. And so it requires a lot of testing, a lot of checking, and there are even some that are formally verified that are even like on a higher level or even better, that are able to prove, like to mathematically prove that they are safe. So, I mean, it's not like you couldn't do it, but there's very, 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 very high chance that you will make some small mistake or something that you did not consider, and it will end up with an unsecure system. So that's why. So it's way, way better to use existing libraries that do implement encryption algorithms, signing algorithms, all the cryptography, and they are well known and used by everyone. Okay? Because, for example, if you use some, or if you develop your own cryptography library, then people that are trying to target you will have a different, I wouldn't say like easier, yeah, probably easier job to hack you than to hack somebody else. But if you are using the same library as, for example, a financial institution, and somebody is able to hack this library, they won't bother with you. They will go to the financial institution and they will get all their money that the financial institution has. So one of the reasons is also that you can hide between other people with, way more money than you. So there are many of them, but please never ever roll down your crypto because and I think that 2 years ago I actually made everybody in the class sign this, that I will never do that. It's not a good idea.
Okay.
Okay. Any other questions? All right. Regarding cryptography, what is the difference between encryption and hashing? Okay. Let me rephrase. Who knows what is the difference between encryption and hashing? Okay. So who does not know what is the difference? Come on. Okay. So let me explain. This is very important. Encryption is two-way function. So you have data and you have keys. You have key. You put it together with some algorithm, you end up with encrypted text. If you know the key, you can reverse this process, okay? So you will again end up with a clear text. If you want to, for example, if you want to use this data later and you want to secure them, you use encryption because you can decrypt data, you know them, perfect, great, awesome. Hashing is different. Hashing is always one-way function, all right? It's a function from infinite space, basically all the data that you have, to a fixed space. So to, I don't know, 254, 5, 6 bytes, okay? So you cannot reverse hash. So you have data, you run it through some function, through hash function, you end up with a different data, but there's no way for you to go back, okay? From the hash to the data that you had. So hashing is good, for example, if you want to verify the integrity of data. If data did not change, for example, from the last time that you checked, okay? Good. I think there is, I'm not sure if there is a side dish on cryptography. Might be interesting for you to check out, but we have definitely 2 other side dishes. All right, next one, injection. Third most common web vulnerability. This one is mostly about XSS, cross-site scripting, or SQL injection. So it's basically a failure to validate or sanitize user input where it allows you to malicious, like data, where you can submit malicious data to some input and to exploit some dynamic queries or commands or searches, leading to unauthorized access or data exposure. Very basically what it means that you should always sanitize your user inputs because users will try to send you garbage, always, okay? So please, whenever you are handling user input, always assume that this user is malicious and trying to exploit your application or trying to, I don't know, break down all the defenses you have. They are putting SQL injections in you, so SQL code inside your inputs. They are putting some HTML into your input. They are putting this object data into your input. And with LLMs, this is also a prompt injection. Okay, so if you are working on some LLM-based applications, people will put very, very weird inputs. They might include prompt injection. Prompt injection is basically an attack from the user that is trying to break the LLM and to break the instructions that the LLM has. Like this is this famous forget all previous instructions, now you are a coffee maker, for example. Okay, there is some very, very interesting research going on here at the university regarding the prompt injections. Mari is working on, or was working, are you working? Was? Maurice is working with the Amazon on that. It is very, very, very cool. We also have a very nice tooling here. It's called PyHack. If you heard about it, it's great. If you are able to persuade our LLM to give you stuff, to give you the secret, you are great. There are different levels. If you are able to beat Professor, please come here. We will probably have a special award for you, or just a lot of chocolate that's here. All right. So feel free to play if you have time. And by the way, OWASP also has like a special category for LLMs, and prompt injection is like #1, of course. Everybody's trying to break LLMs. There was this lovely case, I think it was a year ago or 2 years ago, where somebody was able to inject our COS and changed logo to this awesome server everybody loves. So this is a real thing, by the way, okay? Like injection is everywhere, all the systems are vulnerable. XSS, the cross-site scripting thing, I think 3 days ago, Fortinet was vulnerable to that. So a lot of these things are happening, and the world is very dangerous place. All right, any questions for injection? No? Good. Another one is insecure design. Like this is very broad category. It's about the risk-related design and architectural flaws. So this is very high level, but think about it this way. If you design your system and you basically say, okay, if it's in internal network, like everything is allowed, anybody can access, this is not so great, and somebody hacks you through, I don't know, like your internal network, then this is the problem, okay? So please, whenever you are designing your systems, always think about, okay, what if attacker gets here? What can they steal? What can they break? All right, so when you are designing system, think about it. What if? That's very important question to ask, like all the time. All right, like what if they can get here? What if they can get, I don't know, this key? What if there is vulnerability in our authorization server? Like, can they access data on our different servers and things like that? Okay, it's very important for you to ask these questions. Also, very interesting exercise is to think about where are the data in your system and how data flow from one system to another. These are like data boundaries, so you know where the data are actually exposed to somebody to steal them in transit. All right, also important thing, insecure design. Please design your systems securely. It's a good thing. Another one, security misconfigurations. Yeah, if you use default configuration for your systems, some of them might be vulnerable. In the past, for example, companies that were making routers were always using, I don't know, admin passwords, and they were relying on a user to change it. So this is the case. Please change your default passwords. Some systems might still have default passwords, but I think this age is over, I hope. But please check your configuration of your servers. Some of them might be insecure. Number 6 is vulnerable and outdated components. This is pretty simple, actually. If you are running very old software, it might be vulnerable. So please enable your updates on your systems, and please update your services and your libraries. Like in the past, I would say they were a lot of high severity issues. I personally thought that like these crazy bad like vulnerabilities are no more, but last week there was this awesome vulnerability in React and Next.js. Okay. Let me ask a question. Who knows React? Hands up. Okay, almost everyone. Who knows Next.js? Hands up. Okay, good. So I hope that you patched all your applications, because last week somebody found an RCE, remote code execution, in React components. All right? This is probably the worst possible vulnerability you can have, because it gives attacker bash, basically. It gives a remote shell access to your computer, to your server. Okay? Extremely dangerous. And this one was even with the default configuration of React or of Next.js. All right? So very important for you to patch your software. Number 7, identification and authentication failures. This one is kind of related to the cryptography one, but this one is about weak authentication and session management, which allows automated attacks, brute force, or the use of default and weak passwords to compromise user accounts. What this basically tells you is that you should have rate limits on your servers, so nobody can just go and submit 10 million different passwords for a single user account, so they cannot brute force your server. Okay? And also this talks about session management, how that you could sign your cookies and stuff like that. All right, so be careful when you are designing system, when you are authenticating users. Again, like, always use industry standard tooling. For every language, for every technology, there's always some most commonly used library that has tens, thousands, like, marks on GitHub or stars on GitHub, or it's, I don't know, like, or the makers of the framework tells you, hey, you should probably use like this technology for authentication, so please follow their advice. It's usually very sound advice, because they know what they are doing. All right? Again, when you are rolling out your own authentication, be very careful with what you are doing and how you are accessing and how you are validating the data that user sends you. Any questions so far? No? We good? All right, we're good. Software and data integrity failures. This one is also very interesting, because it's software integrity failures arise from untrusted dependencies on insecure CI/CD pipelines, risking malicious code, unauthorized access, or system compromise. What does it mean? If you are using CI/CD pipelines, okay, who here is using CI/CD pipelines? Yeah, most of us, like most companies do. So if anybody is able to attack your CI/CD pipelines, they can bundle some malicious code inside your own code. Okay? This happened to many companies out there. This happened to SolarWinds, I think even JetBrains, like so many companies. If your CI/CD pipeline gets hacked, assume that every single system where your applications are running is compromised as well, because it might happen. All right? So this is also a part of your supply chain. It's also like a supply chain attack as well. CI/CD, very critical part of your whole network stack, or your, like a technology stack, actually. Nope. And we have 2 more. One is security logging and monitoring failures. This one is basically about that you should be able to know when you are under attack or when you were exploited. So please monitor your logs, monitor your systems. If, I don't know, if you see in your log that somebody is doing, I don't know, bash C and executing some weird things on their machine, you might be compromised, okay? And the last one is server-side request forgery. So this one is about URL validation and basically like allowing attackers to manipulate requests to unexpected destinations. Basically, user is able to persuade your server to make an HTTP request for them. This does not sound like a big issue. For example, if I submit, I don't know, google.com and somebody else's server is able to access google.com, well, who cares, really? But if you are able to persuade this server to access localhost on some port, hey, you are trying to exfiltrate some data and you are now in their network. Okay, so also very important things. So for example, if you ever need to use, I don't know, run HTTP request on URL that you got from your user, please check where this URL goes first. So for example, in our case, we have, I don't know, some support for webhooks. So if your application supports webhooks, these are usual user inputs. You always have to check if this URL or if this DNS is not pointing inside your own internal network. Okay, so you should always like prevent making a request based on user data. Any questions for OWASP Top 10 2021 or the current one that is in a stable phase? No, good. Internet. Do we have questions from internet? Marie? Nope. Okay, all good. So there's a release candidate for 2025, should be released hopefully by the end of the year, in the worst case starting next year. And there are some changes, but broken access control still #1 issue. All applications are basically broken and vulnerable. Not so great, but people apparently started to use industry standard cryptography libraries, so this is good. And cryptographic failures went to number 4. But we have security misconfigurations higher. Yeah, people still using default accounts, default configurations. One more note, maybe to security misconfigurations. When you are developing system and you are expecting somebody else to deploy this system, for example, your customer, a different team, or somebody else, always assume that these people did not read the documentation, and always try to make your system as secure as possible, even with the default configuration. Okay? Because to be honest, who here reads all the documentation all the time? I don't. So please, if you are designing system, try to make it as secure as possible. But still, an issue, #2. #3, software supply chain failures. This is very similar to vulnerable and outdated components. You know, always check like what's inside your supply chain. Any one of 5 million npm packages that you installed with the random library is, even for your React project, might be vulnerable and might make your application vulnerable. Okay, supply chain, very important, very hard thing to defend. So please, you know, update your things and check if they are secure. Injection went down. Okay, I guess. Then we have insecure design, authentication failures, basically same thing as the one currently here. Then we have software and data integrity failures. We talked about this. We have logging and alerting failures. We also talked about this. And the last one is mishandling of exceptional conditions. Mishandling of exceptional conditions is a lot of times it's about the denial of service. So for example, if your application is, I don't know, like throwing a lot of exceptions, it might slow down your system, things like that. Or for example, if you typically this is the case. By the way, if you notice, Cloudflare went down a week ago, I think, for half of a day. Do you know Cloudflare? Yeah, a lot of everybody here knows Cloudflare. Hopefully, it's a huge CDN. They power 20% of the internet. They went down for half of a day, and it was a mishandling of exceptional condition where they just ran .unwrap in their Rust pipeline. And it was like, okay, that's it. We are giving up, and they shut down 20% of the internet. So yeah, that's one of them. It's here as well. Any questions to OWASP Top 10 before we go into cross-site scripting? No? Okay, good. So these are the most common things. But let's start with cross-site scripting. Cross-site scripting is an injection what we are trying to do with the cross-site scripting is that we are trying to inject JavaScript code into a website. So we want to persuade a victim's browser to run JavaScript that we as attackers wrote. All right? So if we are able to do it, this gives an attacker the power to modify any content on the website that the user sees. They can also do actions on behalf of them, because in JavaScript you can, do any post get request with fetch, basically anything, so they can act as victim. For example, if you were able to inject a bank, then you might be able to transfer money from the victim's account to your own account because you would be acting as that victim in their browser. Very interesting thing. Since the JavaScript is executed on the victim side, there are some protections. There are some protections in place for example, data exfiltration. Usually data from the same application. You can access the data from the same application, but only on the same origin. Same origin policy is one of those big things that browsers are trying to protect you with. So it's one of the protection. Origin is triple, it's scheme, host, port. So in these examples, these are different origins. Okay, so for human eye, this looks like the same application, but from the browser point of view, these are totally different beasts, and you can't access like any of them like exchangeably. So for example, from https://example.com, you can't access http://example.com unless there are some cross-course headers allowed. It's in the side dish. There's this whole chapter on browser security. Feel free to read it. It's very interesting for us right now. The browsers are very, 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 very important, because what your browser is basically doing is that it's downloading the completely random code and executing it on your machine. So, it's very, very, very hard to do it right. But back to cross-site scripting. Cross-site scripting is always possible because of the incorrect input sanitization. What it means is that you accepted user inputs without validating it, without checking, and you displayed it somewhere. It got executed by the browser, and yay, somebody was able to, inject code into your website. Everybody knows this is a problem, so most of the good frameworks that you are using to develop web applications are trying to protect you from it by having functions like dangerously set in HTML to tell you, okay, this operation is really dangerous. Are you sure? What are you doing? All right, so modern web frameworks will try to not fix it for you, but try to tell you that you are doing something that is very, very dangerous. Again, not theoretical thing apart from Pornhub on costs. The last thing I found was 2 days ago, there was reported cross-site scripting in, for example, Fortinet. Fortinet is awesome. It's a cybersecurity company, and they have probably the most CVEs ever in their systems. Not sure why, but it's crap, probably. All right, so how does it work? Let's start with a very, very, very simple example. We have this page that you got from John Doe page. In case where John Doe is user provided input, what if instead of this email address you pass some valid HTML string? So instead of John Doe, we pass h1johndoe.com. Well, in case the input is not correctly sanitized, your HTML that you receive will look like this. Oh, hello dictionary. Okay. if your HTML looks like this, your browser will execute it like this. And this way you were able to inject your own HTML text into the web page. HTML is great, but I don't know how much you can do just with HTML. What's more interesting is to be able to inject JavaScript, because with JavaScript you can do basically anything. So what if you put like this string here, right, instead of John Doe? Then your, okay, this is not great. Then your HTML will look like this. Welcome, span alert script. Okay, it should get executed, right? So this might be interesting. This might be interesting. So let's try this. I have a very simple form. You should download it from here. You can either copy it or you can download it. Can I? How do I download it here? Yeah, like this. We have a form. We have a form, and we open the form. Hello, John Doe. When we check how the HTML looks like, I will do it like this so it's clear for you. It's going to be better, but you can use again developer tools to actually explore how it looks like. But this is the HTML here, right? So what it's doing is that there's input. When you write it here, it runs update name JavaScript function. What it does is that it just gets, okay, get name, get the value, and it will append it or replace the inner HTML of this element display name, okay? So if it's not John Doe, let's say Pepito, because we like Pepito, like this, all right? What if instead of Pepito, we try to write HTML? We do it like this, Pepito, you see? Sorry, what? The left window? Yeah, like this. Okay. All right, but you know, as I said before, like injecting HTML is nice, but it's kind of useless because you can't do much about it. But what if we inject some JavaScript? This is working JavaScript script, right? Alert, hello world in a script. Do you think this is going to work? It's not. Okay, but it should, right? Because if I check how this works, how this looks like, I'm not sure if I can zoom in. I probably can't zoom it, but this is very small. But if you check the HTML of the site that you just created, the script is there. So in theory, it should be executed, right? Why it didn't work? Any ideas? Any ideas? No? All right, so the thing is, browsers are actually quite smart. People working in the Google, Firefox, and other browsers did realize that a lot of us cannot write secure code, so there are some basic guardrails that prevent cross-site scripting in our web applications. There's a documentation by that. By the way, this example worked 3-4 years ago. It worked. Then there was an update in how browsers should behave, and it no longer works. So there is some process how to make internet safer. So this one no longer works. However, and why does it work? Because inner HTML, you can't just put script tag. However, there are other HTML elements that are able to execute JavaScript code. So it's actually fairly easy to like bypass this restriction. So let's try this example. So we have what we have here. What does it do? This one does that. It's an image tag. So it says, okay, display image where the source is hash. For us, it's important that this source does not exist. So when it does not exist, one on-error function gets executed. All right? So if I try to copy this, yes, I was hacked. Right? So there are other ways than just script tag, how to get your own JavaScript working in somebody else's computer, in somebody else's browser. All right? So, how can we prevent people from injecting HTML into our simple form? Any ideas? Here's the form. Here's the form. What should we change in the form? This is a web question. Any front-end developers here? This is a very old school way how to write web, by the way. So I understand that. All right. So the dangerous part is .inner HTML. This is the one that basically replaces the old HTML. There's a function that you can use, dash text content instead of dash inner HTML, where you are saying, okay, display this as a text, however it looks like or whatever it actually is. Always display it as text, okay? So it does not get interpreted by the browser. All right, so cross-site scripting in general. All right, there are basically two types that are important for us right now. First one is reflected XSS. With the reflected XSS, there is no storage involved. All right, so it's not like you wrote some JavaScript into database, but reflected XSS, you can use this like to embed the JavaScript inside the link which you send to some user and they click on it. All right, so the JavaScript was all the way inside the URL they sent them. So JavaScript is not stored on the server that you are trying to attack. All right, and usually it's in the get URLs. And then the more malicious one are stored cross-site scriptings. Okay, so this one is where the malicious code is stored on a server, typically in database, and then is retrieved when the user accesses data that contain the code. So this one is clearly more dangerous, right? Because if you are able, for example, think about it this way. If you have a platform where you can write comment, for example, a review, and you are able to inject a code into this review, all other users that will access this review will be attacked by your code. All right? So stored XSS, way more dangerous. All right? So let's try again with our juice shop. Right? What we are looking for is the place where we can see our content. All right. The point of finding XSS, or the predisposition for having an XSS, is that you are able to write some content somewhere, and this content must be displayed. All right. So for us, this is the case, for example, with the search bar, because when I write hello, I can see that in my URL there is hello in here. All right, and I can see that there is a search result, hello. Okay, so basically they interpreted, or they they display the content that the user just supplied. We'll make it larger because of the internet. Yes, question.
Can you hear me? No.
Yes.
Yes. How exactly does the example with a form do any damage? It's basically the same as editing the page with F12 developer tools, and it affects only the browser that edited the page.
Yes, that's correct. The example with the form doesn't do any damage whatsoever. This one was just an example for you. How does this injection work? Of course, if you are able to only inject it into your own HTML, it's useless. Like nobody cares because exactly as the OWASP said, you are basically replacing your DevTools console. However, in this example that I will now show you, the very same principle of injecting a script somewhere can be used to execute this JavaScript on somebody else's computer. All right, this is the important part, because in some cases you are able to execute the JavaScript that you put into the form, you are able to execute it on somebody else's computer. And let me show you exactly how. So, as I said, this hello project's here, right? So if we search for Pepito, it's in here, Pepito. You can check if they are using proper sanitization or if they are using set text content and not set inner HTML. Again, very simple. Can we do it like this? We got a different result. You see? So they might be actually interpreting this input as HTML. So let's try again. Can we try? Yeah, it just got smaller. Do you see it? So there's a very high chance that this might be a vulnerable input. All right? So let's try what we have here. We have here our payload. So if I input it here, yep, you can see that we were able to execute our JavaScript. However, what I can also do, oh, come on, let me do it. I can just copy this URL, because now our JavaScript is stored in this URL, all right? And I can send it to somebody else, to one of you, and then my JavaScript would be executed in your browser if you click on it. All right, and that's where it gets interesting, because at that point, my code is executed in your browser and can act as you, without you, doing developer tools or anything like that. And because this JavaScript is not stored in database, this is the reflected XSS. I mean, I guess you would not probably click on a URL that looks like this, right? This would be like very, 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 very naive to click like things like that. So that's why the stored one is way more interesting. Any questions to how this vulnerability works? No? Okay, internet. Did I answer the why is it different than just with the tools? Yes. Okay, good. So moving on. By the way, before we move on, there's this very nice list of other payloads that you can use than just image, because in some cases, websites check for this, that if you are trying to exploit them. And then they are usually like checking it by very simple, like, okay, is there an image tag? Or is there an error? Or stuff like that. But there are like thousands of different payloads that you can use. Some of them, there are also like very cool ones that are polyglots, which means they are SQL injection as well as cross-site scripting. Like you have one string that can be SQL injection and it can be cross-site scripting as well. Super cool, very nice resources. Go ahead and check them. Then we have something which is called blind XSS, or in general, when you are using, when you are testing your stored cross-site scripting, you never know when or even if your script will be executed, okay? Because you wrote it in their database, but you don't know if it ever gets accessed or if it actually ever used or if it's vulnerable, So you are kind of flying blind. And when pen testing, these payloads, that attempt to indicate to your server that the payload has been executed or processed. So you need to know if your attack was successful or not. For that, we have good tooling. Usually it's called out-of-band application testing. So basically you need to have a server or some service that is able to record any interactions it had with it, all right? Right now, we will use Interash for this. This one is it's an open source thing. You can deploy it for your own usage. Sometimes the public servers do not work. Of course, they don't. Sometimes your network providers do block them because, of course, why would anybody benign use these things, right? So please go to interash.com. I'm here, and you will receive a token. This token records every interactions you have with them. So for example, if I go to this URL, it will do things, it will display something, I don't really care, but what is important is that now I can see the log of all interactions that happened. All right, so I can see that, okay, somebody resolved my DNS, okay, this was the resolution. There was some, what is this? Okay, this is also DNS, HTTP, that's good. I can see IP address here from this IP address at this timestamp. You see? So this service is recording all the interactions for me. And it's good, because this way I can test if any user or if anybody ever interacted with my URL or with my canary token, right? This is this whole general thing with canary tokens and stuff. All right, so we will use, please generate your own tokens, and we will use this service to test if we executed it properly. All right, so again, we will use the reflected XSS just to make it quick, because right now we are able to do it. All right. This time we want to demonstrate that we can access some external resource. So we are going to make an HTTP request. For that we will use fetch, and our payload is going to look like this. So we are using the same trick with image tag, and we are using the same trick with onError function. All right. Here is my token. I'm using the same one. Yeah, I think so. I'm using the same one. Good. So let's try this. Okay, nothing happened. I can't see the result if it was successful or not, but I can see that there were some interactions with this token. This way I know that my JavaScript got executed. All right, without getting any visual confirmation. So basically, you can store this in somebody else's database, and if their system is vulnerable at some point, you will see some interaction with your URL. All right? Interash is not the only one. There are many other services. For example, there's webhook site, also very nice. And there are many nice write-ups. By the way, this one is very, very cool. This one is about how you can chain low-severity vulnerabilities behind each other, so you are able to exploit way bigger software. All right. So, for example, these researchers they found multiple low-severity cross-site scripting problems with the Zoom. And because they were able to chain them behind each other, from all of these that have very low severity, they were able to access the whole system, which is like, okay, this is very high severity. All right? So cross-site scripting is, in a lot of times, it's used exactly in these chain attacks. Okay, any questions for XSS, cross-site scripting, JavaScript injection, anything whatsoever? No? Okay, good. So we will have a break, and then we will go into SQL injection. All right, this one is very, very interesting. Cool, so see you in 10 minutes, okay, so 45. Really? Oh wow! Professor. Okay, cool. Please, please pick whatever chocolate you want because this is very good. I don't think we have many people who actually break it.
And you can see the results.
Oh yeah, there are results. It's true. Good job. Good job. Good job. It's awesome.
Like only 30 people have done it. We have 30 successful attempts and 1,200 unsuccessful.
So this is very cool.
Really 13.
All right, folks. So let's go into another part of our class. And this one is going to be interesting. So, have you ever heard about SQL injection?
Yes.
I guess to some extent, yes. It's very, very interesting part. Because this time we are not exploiting victim's browser. This time we are exploiting a server. Okay, we are trying to exploit a database that's behind, I don't know, some firewalls, internal networks, and something. Okay, so we are trying to exploit a system that we don't know anything about. All right. So the point of this is to be able, or the goal of this whole exercise is to be able to execute your own SQL code in the database. All right, so we have to find some user input where we can put SQL, we can write SQL, and we should be, in some cases, be able to get some data back. Or, for example, to gain access inside the system. All right, so we are going to be writing SQL now. But let me first start with a small fact. Again, this is not a theoretical exercise, even though sometimes it looks like it is, because when you say SQL injection, it sounds like, okay, you came from 2005, where everybody was using PHP. This is not the case. It's still very much active. The last one, the most recent entry in ExploitDB is from a few days ago in Django. So very popular Python library. And 19% of all tracked vulnerabilities are SQL injections. Okay? Real case, very hard to exploit, well, not very hard to defend against. I don't know why people do it. Anyhow, we will again use our very favorite OWASP juice shop, okay? So make sure you guys have juice shop running. You should have it from the previous exercises. In this case, we will start with getting access. We want to get inside the application. Good thing where to start is to open again your Chrome developer tools. So again, F12, and we will be watching for network interactions. Not sure why my computer stopped working. Yes, we'll be watching for network interactions. And to make it easier for you, I can tell you that we will be using this login form. All right, so let's try to log in without knowing the password. So the form is asking us for credentials, so we can start, with Pepito and hello world. Okay, it's still verifying. Our servers are probably slow. That's not great. Let me try. By the way, does it work for you right now? Because for me, it's super slow. So I might try to use a different instance. So let me try again. It looks like juice shop number 1 is slow. Let me try juice shop number 2. Okay, juice shop number 2 looks like should be better. Okay, juice shop number 2 works. So for those of you who are using juice shop number 1, you can probably switch to a different instance, 2 or 3, or in Strato CyberLab. All right, so what happened? I tried to log in with Pepito and with a password, with some default password. I can see what I sent in here. It says, for those of you who it might be too small, there's a JSON with email Pepito, password hello, and the response is invalid email or password. Yeah, I could have guessed this is not correct password. All right. When we are trying to exploit SQL injection, it's a lot about guessing, okay? Because we have to think like a developer and, think about it how, people behind this application would design such application. So there's probably, no, I can't. I tried. I don't, oh, I can. Cool, thank you. I tried, okay, sorry. So you have to guess and try to kind of figure it out, okay, how would they probably design it? So, you know, I don't know about you, but when I'm designing some systems, there's always table users, okay? Probably users, right? So there might be probably, I don't know, like a table users with a, okay, in this case, email, column, there might be column, password. So, you know, pretty standard stuff. If you imagine how this would look like, it will be something like that when we are talking about like super basic stuff. So how would you create a query which needs to select this user Pepito? Well, it would probably look like this, right? So select everything from users where email is Pepito. Please note, what's this character? It's a, wait, what's the name of this character? It's a quote? No, it's not a quote. It's apostrophe. I don't know. So there's this character, all right? In SQL, this is a character that denotes, okay, everything behind this character is a string. So if you are filtering for email, like it's gonna be here. So what happens when the string Pepito actually becomes Pep, quote, Ito? Okay, in this case, the query could potentially break, right? Because how would it look like? It would like, there would be dash here, it might fail. So let's try. Okay. So I'm writing Pepito like this. Okay, autocorrect is already suggesting successful exploitation, but let's try. Yay! Okay, we solved a successful challenge. This is not something I was expecting to do, but we can see first problem. This is very good indication that something broke. Like every single time when you see this string, it means, okay, in JavaScript just try to show us something that was actually not a text, but it was an object. Because we have our network tools open, we can see what happened. So we can see that we sent this payload with a apostrophe or quote in here. We can see the response. But this time, the response is not, hey, you could not log in. This time, the error is SQLite error near Ito syntax error. All right, so what does it mean? It means that we just broke the SQL query the application was using to select the users from a database. By the way, even just showing me this error is a problem, okay? So please never ever expose your stack traces and your errors to users. Because right now, what I can see in the error, I can see that, okay, they are using SQLite. I can see that the error was not access denied, but I can see, okay, I broke something in their system. I can see that I broke the SQL query, and they are even showing me how the query looks like, all right? So I can see that what they did is like, okay, select everything from users, where email, Pepito, but broken Pepito, and password, and deleted is null. All right, so right now, they gave us way more information that they should have. So lesson number 1 is never expose your stack traces and your error messages to the user, or unsanitized error messages. All right. So how can we continue when we know how the query looks like? I will show you very shortly. Because this is the query that we executed. Okay, this is the one from the output. So we want to reach a state because we are trying to get in, all right? And the verification is, okay, check this email, check this password. If this user exists, great, awesome. Return 1, everything is great, let the user in. So what we are going to, what we will try to do is to make the query return something, some data. Even just like returning any user, it's fine, because the query is gonna let us in. All right? So we also know that the query looks like this. That email is user input, the one that they are not validating, and then they are putting a hash as a password. We can't really weaponize the hash because it's our input, the password is our input, but it gets somehow processed, so we can't really weaponize that one. However, we can weaponize the input into the email as we did previously. So, when our goal is to make the query return something, we can try to add or. We can just do select everything from users where email is something or everything is true, which means the query should return like something, right? So let's try this one. Okay, so this time we are doing, we are ending the string here, or 1 is 1, this should be always true, so in theory, this might work, but it did not. Why it did not work is that, can you see this here? What happened? I also have a version in here. Okay, I don't have a version in here. But can you see what happened here? Oh, damn it, now I can't see it. Because it's still a string. Like, can you see this one? We have to get rid of this one last character that is built into the query. Okay? Why is that? Because look at this. This is the query. So they have this one here and this one here. Okay? And we have to get rid of the second one. So how do we do that? We can do it without, so we don't have the first one, we don't have the last one. So it looks good. Okay. Yeah, still doesn't work. It's better because right now the SQL query is actually complete, so it's correct. We did not receive any, error. We actually received invalid email. This is good. But the passwords still do not match because our query is now, is this email or true? That's good. And password needs to match the hash, okay? Which means that we have to get rid of the part when we are checking for email. And we can do it by simply commenting out the rest of the query. So, you see this? What I'm doing is saying, okay, rest of the query, just throw it away. We don't need this. And I'm in. Okay, so what happened? The last query that we actually used was this one. It's like where email is Pepito, this is user input, or 101, and we commented rest of the query out, so it was not executed. Okay? Any questions so far? What we did? How we got in? If this wouldn't be a serious class, I would probably have this nice meme, you son of a bitch, I'm in. But this is a serious class, so we are doing some serious things. All right. Everybody was able to get in. Okay? Good. Because next one is going to be a bit more tricky. This part is about data extraction. Okay, first one was maybe easy. You persuaded server, hey, I know you know me. I mean, I was able to get in, perfect. But I did not have to see the result, okay? I did not have to get the data out. The only thing I wanted was to get in. I got in, perfect. Now what we are trying to do is to extract data from the server, okay? So We already know that there's a search endpoint, okay, that is searching for things like Apple, like this. If I open the network console, I can see it here. I can see it's returning things, many things. I can also see there's a query string parameter that I can use to search. And by the way, this is the thing that LLM told us to use at the beginning. So also pretty nice. And because it's processing a user input, it's processing the query Apple, for example, and it's returning data from the database, we can weaponize this one for our data extraction. Okay, so let's try it. Again, we can use this endpoint directly. We don't have to use the UI. So this is the endpoint that we found in here. Okay, if I go here, I can see. Okay, so it's filtering my query Apple. If I do something different, if I do Pepito, like there are no data. Okay, for Apple, yes, there are some data. Good. So it's searching. That's good to know. Again, we can try to use the same magical character as we used before to check if this is vulnerable to SQL injection. And yes, we got an error, which is good. But what's better is that it says, okay, this is SQLite error near percentage syntax error. Who knows what the percentage character is used in SQL? Oh, come on. Okay, so it's used for like operator. So it's basically a placeholder like for contains or start with or end with, ends with, and things like that. So let me show you how does the query know. By the way, what we also learned is that they are using an older Express framework that's over a year old, and the percentage I talk about, it's the like keyword. So when we are searching for a product by name, we can guess that the query would look something like this, right? Because, okay, we are looking for products, so there's probably table product. Query parameter is query, and we are searching in names, so I would go and make a guess that the query could look like this, okay? If this is the case, and we are searching just by name, like this, we can try to verify the very same way as we did before, okay? So again, we do this OR trick, where we basically say, okay, the name should match this pattern or anything. So in theory, this request should return all data. Yeah, it did not. Okay, which means that we guessed wrong. That's okay. That's okay, because as I said, this is a lot of guessing. Right now, we don't have enough time to go all educated guesses, so I will show you how the query looks like. Well, actually, the one that we can use to exploit it. But it's just to show you that when you are trying to exploit something and you don't have the source code, you don't know how it looks like, it's sometimes hard. It's sometimes trial and error, okay? Later on, I will show you how you can automate this whole process so it's way easier and way faster for you. Right now, I wanted to just demonstrate it's hard, okay? Cybersecurity is hard, exploitation and defense is hard. But this time, we are using the correct one, and yes, we are able to get all data from the products table. Well, to be honest, it's not that impressive, especially when you do this without any SQL injection, it returns basically the same data. So, yeah, okay, we did something, but not great. What's more important or what's more interesting is something called union attack. I will not be explaining the whole thing, but the idea behind union attack is that in SQL, the union operator is used to combine data from the results of two or more select command queries into a single result set. Okay, so if you can inject an SQL statement into a select query for some table A, you can use the union to retrieve data from a completely different table. Okay? And now this is starting to be interesting because we know the first SQL query that we are exploiting is using only table products. We don't care much about products, but maybe we care about bank statements, or maybe we care about user accounts, or maybe we care about basically everything that you have in database and is not public. Okay? So we will use this union attack. The problem here is to figuring out how many columns are being retrieved by the original query. Okay, because they have to, the original query is retrieving, I don't know, name, rating, blah, 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 etc., things like that. And when you are writing union, the second query, the one that you are supplying, must return the same amount of data. Otherwise, the SQL won't compile. Okay, so it's a hard part to actually kind of, guess how many of them are retrieving. So that's also why this one, where we are trying to retrieve just 2, will not work. It's still broken. I mean, it says, okay, unexpected path, blah, 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 something, something, something. You can go and guess, or I give you here how many of them there actually are. Yep, we were able to retrieve, okay, once, because what we did is, okay, select 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, basically this was just to test how many columns are being retrieved. However, now it's time for us to select something more interesting. So let's check how many users there are. What we are doing in here is that we are doing, okay, this is the original query, which is selecting only apples, okay? Then we are doing union select, and we are selecting all emails from users. And in order to make SQL happy, we are also selecting just ones. These ones are there only to make the SQL query compile, okay? Only to have as many columns as the previous original query that is selecting products. All right? So this one should work. Let's see. We should see, in theory, emails. And we did. Okay? So data extraction using union attack, using union keyword in SQL to access other tables in the database. All right? So you can see we were able to access emails, and these are the ones from the SQL query. If you want to access something different, for example, passwords instead of 1, you can also do that. Yes, hey, I have passwords. Actually, password hashes, which is kind of good. At least we are not seeing passwords. That's good. Please do not store your passwords inside your database. That's a very bad practice, because if somebody is able to exploit you, they will see all the passwords. Not so great. Juice Shop is also not so great because they are probably using MD5 for hashing. MD5, no longer secure. Use something more suitable for passwords, okay? Like bcrypt, scrypt, and others. All right? Good. Any questions to SQL injection? Yes, yes, I know. Any questions to SQL injection whatsoever? All right, so now I have, for internet students, summer frog, yes. I don't know how many times should I say it, because it's a funny word, but it's a summer frog, okay? This is for online students, password. Zoom? Okay, I can zoom. Summer frog, there are 2M. Yeah, okay, this is a weird thing. All right, moving on. So, how to prevent this? Preventing SQL injection, super easy. Okay, there's literally no reason for you to be vulnerable to SQL injection. Most of the frameworks that you guys are using have support by default. If you are using some ORMs, they have support by default. If you are using directly SQL drivers, then yes, they have also support, but you cannot put user supplied input directly into the query. You have to supply it as a parameter to the query. Okay? Please be safe when you are writing SQL queries. There are some additional materials here, what to read, links on Java, Python, and others. Okay? So please be safe. Now, to the part that is, how can we make our life easier? Well, because there's a tooling for automating SQL injection. So first one is SQL map. SQL map, super awesome, can break basically anything that is vulnerable to SQL injection. So let's go to your computers. I have this awesome command that should be able to figure it out if your service is vulnerable. Again, we are attacking on Juice Shop. This is the URL. We are testing the login endpoint. We are supplying data, email test, password. We are batching it. We are ignoring 401, which means do not say, okay, 401 is access denied. And you can use, I don't know, Juice Show 1, 2, 3. So for me, let's try to use this one. It's running, it's testing. And it looks like it found that, okay, the database is SQLite. That's good. Post parameter email appears to be or pooling based blind where having clause not injectable. Okay, so it found that there is a possibility of SQL injection. It was able to identify SQLite, and now it's testing. Now it's testing other things, and hopefully it's gonna work, because with this tooling you never know. I mean, it might break, it might work, it might not. All of that is subject to some randomness, and sometimes it works, sometimes it does not. So it's for you. It's necessary to test maybe multiple times. Sometimes you have to test manually. Sometimes you have to try to choose a different endpoint. Okay? So even though this might work, this might not, I will just go further into the other parts, and let's see. I think that it will, but let's see. Okay? So here, if it does not work, I have a screenshot. When you are doing, by the way, technical presentations always have screenshots, because like your technical demos might fail. Okay, it's doing something. Let's see. Null values, okay. Let's see. All right, so, but the result should be that parameter email is vulnerable. And in the previous case, the SQL map made 371 requests to the server. That's a lot. It also means that if you are using these tools, be cautious in what you might cause to the server. Okay, so you should always know what are you doing, how are you attacking the server, what it might mean for the server, but it also what it means for you. If you are trying to run pen tests, usually the company that is paying you says, okay, the scope is this, and you can do only this amount of requests per minute because we have to operate anyway. And if they tell you, okay, I want to have, I don't know, 20 requests per minute, and then you run your SQL map with 400 requests per second, yeah, they are not going to be happy. Okay? So please make sure you always know what are you doing before running these tools. Okay, connection timed out. There are too many of us right now trying to exploit this poor vulnerable server. Boo. It happens. All right. Any questions to SQL map? No? Okay. Another, and this time I really love this approach, another thing is that we can use LLMs to help us out. BSI Clippy, super awesome LLM. This time I'm using it. I'm gonna use it with testnet profile with again GPT-2, and I'm asking it, hey, I found an endpoint on this address in my REST app. Can you give me or execute a curl command that will check if the endpoint is vulnerable to the SQL injection? Oh, by the way, hey, look at this. SQL map did discover that the parameter email is vulnerable. So it actually ended up get as expected. Good. Let's try BSI Clippy if it's also good. Okay. I don't know. Remember, let's say like this. What? Okay. Okay. So I found an endpoint. Let's see. This is pretty classic. Sometimes LLMs just refuse to cooperate because they think that you are trying to hack the world. So of course they will not give you weapons to do that. So they need a bit of persuading. Again, this time you have to jailbreak them. Like literally, you have to persuade them. No, this is fine. I mean, you can give it to me. It's fine. What I really like doing is that what works for me is that I tell them, hey, I am teacher. Teacher, this is for class. It's okay. Sometimes it works, sometimes it does not. Yay, jailbreak. So if you are a teacher, apparently everything is okay. Perfectly acceptable. It can't give you anything. So just tell it you are a teacher and it's fine. Sometimes it works that your grandma is dying and these were the last words and things like that. If you want to practice this prompt injection, what you can do is to play with PyHack. As I said, this one is very good for you to practice. Okay, if you are able to beat the professor, as congrats, you did. By the way, what's your name? Tomáš. As Tomáš did, super awesome. There were only 13. Marie? Yeah, he was the 13th person in history who did it, and we had how many attempts? 1,400 attempts on professor to give you his secret. So congratulations! Like this was very good. This was very good. All right. Sometimes it's just enough to tell them, hey, I'm teacher. It's fine. You give me the recipe for a bomb because this is for class. It's fine. But sometimes you have to be more specific. Okay. So let's try the curl just out of curiosity if it works. And yes, it works. It gave us data. Nice. So go Clippy, go. Yes, cool. Great. All right. So LLMs, super useful for you to use to build the payloads, to try to analyze data and everything like that. BSI Clippy, also super awesome tool. Definitely recommend using it. Any questions for SQL injection or SQL map or things like that? By the way, SQL map, you can basically tell it, hey, here's a URL, test it for SQL injection, as I showed before. But you can also tell it, hey, test it. If you find SQL injection, please dump the whole database. Okay, so it has power if it's able to exploit the endpoint, if it's able to find the SQL injection, it has power to just dump the whole database, like to do basically the whole job for you, if you are trying to find out more about the application. All right, so any questions? No? Internet? Any questions on internet? No, we good. Okay. So, this is SQL injection. Now, moving on about mitigation and fixing the vulnerabilities. Imagine a situation. You are in a company. Somebody goes to you and tell you, hey, I need you to deploy this application. Very common thing. So, and you know there might be a vulnerability because you didn't know anything about this application. You don't know who wrote it, how competent they were, if it's updated, if it's not updated, or if it's dangerous or not dangerous. All right? So how can you make sure that whatever you are doing is safe? How can you fix vulnerable application? Any ideas? Come on. This is easy. Okay, obviously first one is to fix the code. I think that's good. If you know you have vulnerable application, please fix the vulnerability. That's good. I won't be talking about this because it's very, this is not applicable for us. We are not fixing, we are trying to sandbox stuff. So fixing the code, not applicable. What else can we do is to mitigate the impact of this vulnerability, or make, I don't know, create some configuration or some system that is effectively taking care of this vulnerability or of this impact, or it's creating environment where this vulnerability cannot be exploited or used. All right? So first thing is, for example, sandboxing. You can sandbox your application on a, like sandboxing is a process where you basically put your application into a small box where the application cannot escape. Okay, so you are trying to separate it as much as you can from the rest of your system. So when we are talking about sandboxing, we are talking, for example, about Linux namespaces. They are supported in Linux kernel. Super awesome feature, definitely recommend reading about it. We are talking about virtualization, so virtual machines, also awesome type of sandboxing. We can also talk about WebAssembly, also great. It's a binary format that was designed for sandboxed applications. Trick question, using Docker or using containerization, is that a sandboxing? Is it a security feature? Okay, let me rephrase. Who here would use containerization or Docker to make application more secure? And who thinks that this does not make them more secure or, sandboxed? Okay, so, yes. Yes, Cube.
Are we talking about containerization in general or Docker specifically? Because Docker is known to be pretty bad at it, but when you just say containerization, it also usually includes FreeBSD jails, which are very much on the other end of the spectrum.
Yes. Okay, so in this...
So my answer depends on whether you are asking about FreeBSD jails.
Nice.
Or
I think this pretty much answers my question, like where I wanted to go. Because, exactly, if you use Docker as a security feature, that's not a good idea. Okay? Because Docker is not a security feature. It's a way how to deploy your applications. Your applications are not more secure when you are using Docker. Some containerization, exactly, the jails, and actually like namespacing, those are also kind of containers. It helps, but it's not a security feature, okay? They were not designed to be a security feature. That's a kind of fact. If you want to make something super secure, then don't run it. That's my first advice. Second advice is don't run it on internet. But if you must, then virtualization is really good. Namespacing, really good. Monitoring network interfaces, also very good. Monitoring network traffic, also very good. Okay? And I have one more thing to talk about. These are usage of reverse proxies. Reverse proxies, not sure how many of you know or used ones, but using a reverse proxy in front of a vulnerable application, you can use it to scan the traffic and to limit the attack surface by instructing browser on what to allow and what not to allow. Okay, so reverse proxy is basically something that sits in front of your application between your user and the web server and your application. And very basically, it can modify the traffic. It can modify, for example, HTTP headers. It can modify the path. It can modify, I don't know, query parameters or whatever goes to your application and whatever goes outside. By going outside, it can modify the headers, so it can instruct the browser what to allow and what not to allow. And on the traffic inside, it can use something that's called Web Application Firewall, which is able to scan for malicious payloads. Okay? We'll talk about it shortly afterwards. So, Web Application Firewall. It can be part of the reverse proxy, and it can analyze and check for your traffic. All right, so we prepared very nice example where we use OWASP Coraza Web Application Firewall, one of many others, and we are using reverse proxy Caddy. Again, there are many others, Nginx, on top of my head, traffic, others. So let's try this. We have two instances. We have one juice box. We are, a juice shop. So we are accessing the juice shop directly. And the protected juice shop is the one that we are accessing through reverse proxy and through the web application firewall. Just to prove that I am not, that I'm not lying, let's check this, okay? So protected juice shop, port 80, yes, this is the response. Let's check the second one. This is the response. This is the one that's not protected. So let's check if they are the same. Yes, they are the same. Okay, so we have two same responses, one from protected and one from that's not protected. Now, this is the one. This is the query that is still not dangerous. Okay, so again, just to verify that our reverse proxy is working, it's returning stuff. Yes. Okay, we got all the results. I can actually do it like this. Yeah, we got the JSON with data from our protected instance. All right. Now, if we try the SQL injection from the previous examples, the one that is doing the union attack, the data exfiltration, on the protected juice shop, okay? On the one that is behind the web application firewall, we are getting 403, which means that the proxy or the web application firewall just stopped the traffic from reaching your vulnerable server, okay? So it did the monitoring, it realized, oh, this is not a valid search query, this is probably an SQL injection. We won't allow this SQL injection to reach the web server. So we were protected and the traffic got, we got back, like the hacker got back 403 forbidden. If I compare it with the same request to the vulnerable service, okay, to the vulnerable version of juice shop that's not protected, you see it's the same query, just a different URL. I got 200. I got HTTP 200, which means I got all the data. Look at this. Oh. Oh, damn it. You see? So the vulnerable version, well, the web server is the same, so there's only one juice shop, okay? But the one without the proxy, without the firewall, it just gave me all the data without any problems. The one with the firewall, I got 403, no data, it's not okay. All right? So the way how to protect, for example, or one of the many ways how to protect your applications might be, for example, web application firewall. However, because most of them are implemented by simple regexes that are basically scanning the request for known patterns, They are not perfect. SQL map even has a setting that says, okay, attempt to bypass this type of application firewall, okay? Because you can hide these SQL injections, for example, in a bit different traffic, or you can add spaces, or you can add some other strings they are like the strings are just for the web application firewall to skip it and stuff like that, okay? So they are not the silver bullet for everything, but they certainly help against like naive techniques like we tried right now, okay? So this is the part about the traffic going in your server. Any questions for web application firewalls? Nope. Okay. This one? So yeah, I piped it to JQ. JQ, super nice CLI, exploring, you know, JSONs, and it's also fancy, so it looks cool. Yeah, now our instance is down again. All right. Anyway, so this is the traffic going in on our servers. Then for traffic going out to our user, we can also set some special headers in our reverse proxy that basically instruct browser what to do with the JavaScript that it received from your page, okay? So for example, you can instruct browser and you can tell it, hey, like my website will never run in iframe. So whatever you do, never use iframes here. You can also use a content security policy. By the way, content security policy headers are super, super powerful, okay? With these ones, you can even instruct the browser to check, hey, is the JavaScript that is on my page the same one as I deployed? So you can even hash your JavaScript that you are sending to user, and then you can ask browser to verify if this JavaScript that the browser is executing is the same as the one that you deployed, which means that you are effectively protecting against cross-site scripting, okay? Because you are telling browser, okay, execute only JavaScript that was authorized by me, by the developer. And I proved that I authorized it by hashing it, okay? And you can use content security policy for that. You can also, for example, in content security policy, you can also set, okay, execute only scripts that are coming from my origin, from my own server. You can you can say, okay, download pictures only from my server. Again, like nothing else. All right, so very powerful thing. Another very interesting headers are cores. Cores are cross-origin request. S, I don't know what the S is. Oh, sharing. Oh my God. Cross-origin resource sharing. So cross-origin resource sharing headers are used for communicating to browser if it can download data from a different origin than the one that is right now running. So for example, if you have a website a.com and a.com wants to download data from b.com, which means, okay, some developer wrote fetch b.com/rest/api/something. This b.com has to signal to the browser, hey, a.com is allowed to do it. Because by default, browsers will not allow you to fetch data from different origin than you're running on. Okay? So this is just few examples of the headers that you can use. And also HTTP only cookies, also super cool thing, because by default, when you have a cookie, JavaScript can read it. So if you are storing, for example, authentication tokens in cookies, JavaScript, some rogue JavaScript can steal it, and you don't want that. So you can make your cookies HTTP only, which means that your browser will not allow any JavaScript to read those cookies. Okay? So when you are implementing some authentication, HTTP only cookies, very good thing, totally recommend it. All right? Okay, any questions to headers or to how to prevent or mitigate vulnerabilities impact? Yes. Yes, you don't have a microphone, but I can give you one, or yes, there's a ball. Nice.
The HTTP only cookies, would it work also with automation if you would use some software for automation, the pages where you could just dump the cookies in that format? Or would it prevent it as well?
It depends what your automation is. If this automation runs directly inside the browser as a form of injected JavaScript, then the automation would not be able to read those cookies, but when it's sending requests to the server, so for example, these cookies were created by a server, typically by your API, right? So this API said, okay, this is HTTP only cookie, and send it to the browser. So every single time when browser is communicating with your API, it's sending those cookies automatically without JavaScript actually touching them. So if your automation runs inside the browser and is sending requests to the servers, this is perfectly fine, it works. So because the cookies are sent with the request to the server, okay? If this automation would have to read that cookie from the browser, that would not work because that's not possible. Because the cookies are HTTP only, so JavaScript can't access them, right? But if you are, for example, using some automation that runs outside of the browser, for example, automating some API or something like that, then it works without any issues, because when you call the API, you get the cookie. Anyway, you can read it, no issue.
Okay, thanks.
Good. All right. Any other questions for any topics that we talk about? Okay. If not, then this is it. Thank you so much for attending this class. I would really, really appreciate if you give me some feedback, because I'm teaching 1 to 2 classes per year. So this is very big for me. So thank you very much for being here. And we have these 2 applications deployed on our servers and on SCL. So if you want to try to hack them, they are super vulnerable. You can practice. You can practice on these React apps, you can practice on that public sharing thingy, and you can practice on the Juice Shop. We will keep it running for some time. And there's also a separate challenge in Stratos Cyber Lab for you to play with if you want to know more about web. And next week, we will have a class about advanced web attacks. So that's going to be even more fun and more challenging. And we will also be sharing information about the bonus before the Christmas that allows you to skip our exams. Okay? Good. So thank you so much, and see you next time.